Hello and welcome to topic 7.5. If you hear my dogs, just ignore them. I'm still doing this live at home. Topic 7.5 is called proportions in triangles. And this will probably be a bit of an easier lesson because I got a little trick to show you. Today's learning objective is I am learning to use the side splitter theorem and the triangle angle bisector theorem. And I do have these things on the back of the paper, so if you look, side splitter theorem, there's a corollary that goes with it, and the triangle angle bisector theorem. So it works like this. We're going to first start with the side splitter theorem. It says solve for x, and what I like to do is use the side splitter theorem, which basically says if you have two parallel lines cutting through two sides of a triangle, and one of the lines is parallel to the base, the third side, then what that means is this is like a divide bar. So you could put x plus 1.5 over x and 5 over 2.5 to be your proportions, and that's going to be the equation that we'll solve. And we're going to cross multiply just like we were before. So when I cross multiply, keep in mind since there's a plus there for this set of terms, you want to put it in parentheses, and then you'll cross multiply. 5 times x is 5x, and then bring down your equals, 2.5 times parentheses 1x plus 1.5. And then you want to distribute this 2.5 into the quantity of x plus 1.5 and simplify it. And then you want to subtract the 2.5 to the other side and then divide. And when I divide, my calculator says I get 1.5. And here's how you check your work. If you substitute the x value back in to your original side lengths, 1.5 for x plus 1.5 gives me 3 here, and then x being 1.5, it should be the same similarity ratio for either of these fractions. In other words, 5 over 2.5 should simplify to give you the same as 3 over 1.5, which they both give you a value of 2. 1.5 goes into 3 twice, 2.5 goes into 5 twice. So the similarity ratio there would be 1 to 2 or 2 to 1, depending on what you pick first. Then example 2, you're going to repeat that process. This one doesn't have two terms together with a plus, so it may be a bit easier for you. And if this is our divide bar, which is going to be the parallel line, the parallel line parallel to the base, it would be x over 16 and 5 over 10. And then you cross multiply that, and you get 10x is equal to 80, and then divide by 10. 8 over 1, or just 8, and then this is a coincidence, but when you substitute this back in, the ratio is still 1 to 2, just like the first one. But it could be anything. Again, that's just a coincidence. So 16 over 8 or 8 over 16 would give us a ratio of 1 to 2. 5 over 10 or 10 over 5 would still give us that same similarity ratio. Example 3. The edges of the panels in the cell at the right are parallel. Find the lengths of x and y. So if you look on your paper, which you can of course find on Google Classroom, this has an x here and a y here. We're going to kind of split this into two separate problems. Here's going to be one set of proportions. Here's going to be the other. Now if you're a little savvy, you can see 1.7 over 1.7, those didn't change. So this should be 2 over the same value of 2. Now if you want to actually check and do your proportion, 2 over x, 1.7 over 1.7, and cross multiply it, you're going to see that you will get 2. So if we do that, we'll get 1.7x is equal to 3.4 divide by 1.7, and you will get a value of 2, just like we assumed that we would there. And then your other problem is going to be 3 over 2 y over 1.7. So let's set up that proportion, 3 over 2 y over 1.7, and cross multiply. You'll get 2y is equal to 5.1. Divide that by 2, and y is equal to 2.55. And you can check, and you can plug that 2.55 in here, simplify 3 over 2, simplify 2.55 over 1.7 to see if you get that same similarity ratio from the previous lessons. Example 4. Now this one's kind of odd. This is the triangle angle bisector theorem that we mentioned in our I can statement or our learning objective. It basically says if you take an angle and you cut it in half, like angle S here is being cut in half by line segment QS. You're bisecting it, which means literally cutting in half, both sides are equal. It sets up two fractions here, 5 over 8 and 6 over x. Or you could flip-flop both of those. You do 8 over 5 x over 6. So if we set that up, 5 on top, 6 on top, 8 on the bottom, x on the bottom. And you can cross multiply it. 5x is equal to 48. Divide by 5. And we get 9.6. And if you want, you can substitute that back into here and see, does 5 over 8 simplify to give you the same thing as 6 over x? Now you do have to be careful on the triangle angle bisector ones because you can actually set them up wrong. You don't want to do 5 over 6, x over 8. You want to stay consistent. 5 and 8 are both alongside RP, and then these are the other two sides that are being created from splitting your angle S in half. So those go together. And I think that is basically it besides the corollary, which, to keep it simple, again, here is your divide bar. So your fraction here would be A over B, C over D. So if you see one of these problems on your assignment, feel free to comment and ask questions, but you would set it up the same way. It's like a triangle, but we cut off this piece, and then of course this is still just the base.